Thank you for joining this lesson. We're going to look at differentiation and integration together with their applications in kinematics. That is a calculation of distances, velocities, and acceleration. Number 24. A particle P moves in a straight line so that its velocity v meters per second at time t seconds, where t is greater than 0 or equal to 0, is given by v equals to 28 plus t minus 2t squared. Find part A, the time when P is instantaneously at rest. To be instantaneously at rest means to be having a velocity equivalent to 0. Therefore, for us to get the time when the particle P is instantaneously or momentarily at rest, then what we need is to equate the velocity function to 0 so that we may solve for the values of t or the value of t at such a moment. So I'll be having this function now equated to 0. So we shall say 0 equals to 28 plus t minus 2t squared. Then at this point now we can have 2t to the right hand side squared, then minus t minus 28 equivalent to 0. The equation is now a quadratic one, and we can proceed to solve so that we may obtain the values of t. The first thing to work out is to ensure that the constant is taken to the right hand side, and again the value of t squared is equivalent to 1. Therefore, to remain with t squared 1, we're dividing through by 2. So this one will become 14. After dividing by 2, we shall add a constant to both sides of the equations so that the left hand side is made a perfect square. So to make it a perfect square, we are adding a constant c such that b out of 2 squared is equivalent to such a constant. So negative 2 divided by 2 becomes negative a quarter. Then squared, it will be 1 over 16 and also 1 out of 16. So we can factorize now the left hand side. The square root of the first part is t, then the sign which follows, which is a minus, and the square root of the constant 1 over 4. So now we have factorized squared. We have factorized the left hand side. In case you expand, you will get back to the expression on the left hand side. After that, we can have this other side now being equal to 14 and 1 over 16. 14 and 1 over 16. Then now we take square root both sides. When we take square root both sides, we shall have t minus a quarter equals to plus or minus 3 and 3/4. That is the square root of the right hand side. With this now, we can remain with the value of t. That's going to be, to remain with t, now we need 3 and 3/4 plus a quarter, or minus 3 and 3/4 plus a quarter. So the first value of t, this can also be t. So t is going to be exactly 4 seconds, or negative 3 and a half, negative 3.5. And since we are dealing with time, and actually the examiner has already been specified that t is either 0 or greater than 0, then at such a moment we'll be having the value as 4 seconds. We are also told to find in part B the speed of P, the particle P, at the instant when the acceleration is 0. So first of all, we are going to find acceleration function. So we usually say that acceleration function is usually given when the velocity function is differentiated with respect to time. Remember, we are obtaining the gradient function of the velocity function, and in case velocity against time are plotted, their gradient would give us acceleration. That is why the function will help us to get acceleration. So now we need to differentiate the function which has been provided here. When 28 is differentiated as a constant, it will just disappear. Then we have t, which is to power 1, it just becomes 1. Then the other value is negative 2t squared. We drop power 2, so that it will be negative 2 times 2, that is negative 4. And now t becomes power 1. So that is the acceleration function. With our acceleration function, remember we need speed when p is having an acceleration of 0. Therefore, we will equate now acceleration to 0, so that we may first of all get t. This is 4t being equal to 1, or rather the value of t being equivalent to a quarter. So the speed, or rather the velocity at such a moment, is going to be equal to 28. We go now back to the velocity function, plus t, which is a quarter, then minus 2 t squared, so a quarter squared. Then now we compute this 28 plus a quarter minus 2 into a quarter squared. This is exactly going to be 28 and an eighth meters per second. That is the speed. Finally, we are talking about part C. Given that P passes through the point O of the line when t equals to 0, find the distance of P from O. Find the distance of P from O when P is instantaneously at rest. So it passes at a point when t is equivalent to 0, and now we want to find the distance it will have covered by the time it will be at rest. Remember, by the time it will be at rest, t is going to be 4, according to the first question. So we need the distance covered now from when t was 0 up to when it is at rest, and that is at t equals to 4. Therefore, because we are provided with the velocity function, we first of all need to recognize that the distance function, which is displacement function, is given when the velocity function is integrated with respect to time. And in this case, it's a definite integral. So we're going to get a displacement all the way from 0 to 4 of this function 28 plus t minus 2 t squared with respect to time. So now we can integrate and say the first part, 28 being a constant, we introduce t plus t being to power 1. Now it becomes t power 2, and we divide here by the new power, which is squared, minus 2t power 2. This one becomes power 3. So 2t power 3, and we divide by the new power. Then we add the arbitrary constant from 0 to 4. Now we're going to substitute the value of t as 4. Therefore, we work with 28 by 4 plus 4 squared out of 2 minus 2/3 into 4 power 3 plus a constant. We shall be subtracting when we substitute the values of t as 0, and as you can see, everything will just become 0. But let me express it now that it's part of the work. So 28, 0 plus 0 squared over 2 minus 2 out of 3. Then we shall have 0 power 3. Then we add a constant. Let me compute this part, whereby I'm getting 77 and a third plus c, then minus. These are going to be zeros plus c. So c minus c becomes 0. And the value of the distance traveled is 77 and a third meters.